All right, it's just a quick rundown on index laws, and then on to some an index equation, just a simple one where the base is going to be changed to solve the problem. So here we go, a rundown of the index laws. A to the power of 1 equals A. A to the power of 0 is 1. So anything to the 0 is a 1. So 5 to the power of 1 is a 5. 6 to the power of 0 is a 1. This is a common one, this one. I see a lot of people going 3x to the power of 0 equals 1. No, it's equal to 3. The 0 is only on the x. So if you've got 9ab all squared, or just squared, and all to the power of 0, that's equal to 1. Okay, A over 1 equals A. 1 over A is 1 over A. It's not equal to A. A to the m times A to the n is A to the m plus n. So 2 cubed times 2 to the 4 is 2 to the 7. 3 plus 4 is 7. A to the m divided by A to the n is you subtract the indexes. And that's 3 to the 7 divided by 3 to the 4 equals 3 cubed. A to the m over A to the n, that is the same as this one. That's still the same. Let's divide. All right. A to the m all to the n is A to the n all to the m. You can swap the a and the m and you just multiply them. So 5 squared all cubed is equal to 5 to the 6. 2 times 3 is 6. These happen quite a lot. A to b to the p, c to the q, the whole thing's to the m. So you multiply the m on each of these two indices. So 2 cubed, 4 to the 5 all squared. You go 3 times 2 is 6. 5 times 2 is 10. A to the minus n means 1 over A to the n. So 4 to the minus 1 is 1 over 4 to the 1, or just 1 over 4. A of b to the minus n, you can flip this one. It just becomes the flipped version. Take the minus off, and then you can split it apart. That's just b to the n over A to the n. So 5 over 9 to the minus 2. Flip it. All right, x to the power of a half means square root, the positive square root. 9 to the power of a half is 3. X to the 1 on n means the nth root of x. So 8 to the power of 1 on 3 is 2, because 2 times 2 times 2 is 8. X to the m over n, you can either go the nth root first to the power of m, or you can go the power of m first, then the nth root. So you can see two examples here where I do it both ways. Here you cube root the 8 first, that's 2. 2 squared is 4. Or you square the 8 first, get 64. Cube root of 64 is 4. Same answer. Easy. All right, examples with cancelling. If you've got a cubed over b4 times b squared over a, you can cancel across diagonals here. So you do need to know your index laws for this. One of those a's will cancel with one of those up there, so that leaves you 2, and you just cross the a out. There's squared up here for the b, so you get rid of that completely. That becomes a 1, and 2 of these disappear. So it just gives you a squared on b squared. If you have x4, y7z over z, x8, y4, the z's just cancel completely, and similarly, you can see how the others cancel. It doesn't matter where they are. If one's on top, one's on the bottom, it's all multiplied. Cancelling will apply. And that one's just y cubed over x4 if I've done it correctly. All right, let's go to index equations. In the basic principle is, if you've got the same base number, it could be a 2 or a 3, then the indexes, the exponents there, are equal. That's how you solve index equations. So let's do one. 8 to the power of 5 minus 2x equals 16 to the power of x plus 1. So you can see here you can get the same power, the same base, which is going to be 2 in this case. We could do this by logs, of course, and in general you would do that, but when you can do the same base, it's more often better just to use this trick here. So you're going to convert them both. 8 is 2 cubed, 16 is 2 to the 4. Now we need our index laws. You multiply the 3 multiplied by this, put a bracket in. I see a lot of people going 3 times 5 only and leave the 2x alone. So now you can see the bases are equal. You can kind of cancel them. Think about it like that. You can just disappear them. They're gone. So you get an equation. And now, hopefully you can solve the new equations. X is just equal to 11 over 10, which is the same as 1.1. And Bob's your uncle. Thank you for listening. Have a great day, guys. Bye.